All right, I'm going to show you how I check our motor efficiency and check for bad capacitors on a typical PM. It's really quick. So the first thing I'm going to do with my meter, and again, you have to have a meter that can read power factor. This is the Suoco IDVM550. The first thing that we're going to do is set it to the KW feature. And we're going to hit the function button twice, and that's going to give us our power factor. Now, reading power factor is really quick. I'm just going to clamp my meter around one of the incoming leads coming into the unit and then check voltage. When we do that, lo and behold, that top number, that 0.85, is our power factor, and that's really not acceptable. We want to look for something around 0.94 or better. So we know we have a problem. All right, so next thing we're going to do is bench test this capacitor. So we've pulled it off. We've got our meter set for capacitance. We're going to first read the compressor side of the capacitor, so common to Herm. And we'll let the meter settle out. And we're reading 39 microfarads. Well, this is a 45.5 microfarad capacitor, so we're 6 off. It may not seem like a lot, but that is well over 10%, and that is unacceptable. Next thing we're going to do is just verify that our fan side is also failing. So we're going to check common to fan, and this is only down to 1.3 microfarads. Again, it's a 5 microfarad on the fan side, so this capacitor is definitely bad, but we would not have found this capacitor had we not been looking for it. So really easy check. Okay, this is our new capacitor that we're going to check. I always like to bench test them before I install them, just to make sure they didn't go bad in the truck. I've been burnt like that before on PMs and repairs. And we're going to wait for our meter to settle out. And we're reading 46 microfarads. And on the fan side, should be reading 5, and we're reading 5.1. Great. We're going to install this capacitor, and then we're going to check power factor again. As we're waiting for the unit to time out, you may notice I got a lot of wires pulled and I got jumper wires on it. The reason for this is that my customer is not home. I'm doing a preventative maintenance. He's assured me that his filters are clean. He just changed them this week, and I can't get inside to put my air probe in my supply and return vent. So I've got my return inside the unit by the blower, and the supply I placed in the hole that normally the high limit goes into. So just a little bonus tip. I know we're not really talking about using air probes and smart probes and checking temperature on package units and stuff, but if you need to get a supply air temperature, you can remove the high limit and you have direct access to the supply side of the unit. A lot of times you can get a little snake camera in there and check the heat exchangers, and it's just a good little tip. Just make sure you're really careful pulling it out and putting it back in so you don't break the high limit. Check the power factor now. For all you haters out there that may think this is a dumb way of checking capacitors, think about how long it takes for you to turn off the power to the unit, unwire your capacitor, bench test it, wire it back up, turn the unit back on, wait for the 5-minute or whatever time delay to take place, when all you can do is just set your meter to KW. You hit the function button twice, you read your amps, and you read your volts, and we're running 0.91 right now. Still not as high as I'd like for it to be, but I verified that even the blower capacitor is working correctly. The 45/5 capacitor is the correct one for the compressor and the fan motor. That's as high as it's going to get, so we're going to have to be happy with this, but normally your power factor should be well above that, somewhere around 0.94.